a single supertanker, 200,000 tons of crude oil. It navigates a channel, constricted, precise. We are looking at the Strait of Hormuz, 30 kilometers at its narrowest point, a choke point, a single point of failure in global energy supply, protecting this one vessel, ensuring its uninterrupted passage. That task demands more operational complexity. It allocates more resources, far more than a direct offensive strike, against a fixed land target. Such a reality feels counterintuitive. It challenges conventional military logic. And yet, defensive escort operations consistently generate a higher risk profile, a greater expenditure of kinetic and non-kinetic energy. Why? The defensive posture inherently expands the threat surface. It requires constant, omnidirectional sensor coverage. It demands dynamic resource allocation against an unknown, distributed adversary. The variables are not static. They are fluid. We do not consider the narrative, we consider the threat vectors. The variables multiply, the equations shift. This represents the brutal arithmetic of maritime control. A single ship, a global consequence. Such is the equation of the strait. Conventional doctrine dictates numerical superiority. More ships, more firepower, more control. This axiom governs fleet composition. It shapes strategic deployment. Yet, in a literal environment, this principle inverts. Every additional vessel in a confined waterway becomes another node in the threat matrix, not a force multiplier, a liability multiplier. Each one an exposed flank, a potential casualty. The density of friendly assets creates a target-rich environment for the adversary. Without direct engagement, the objective shifts from overwhelming kinetic force to precise risk mitigation, to de-escalation by design. A single defensive breach, a torpedo impact, a missile strike, ignites more than a deck fire. It triggers a cascade, economic shockwaves, geopolitical tremors. The global system is fragile. Consider the math. Protecting a single high-value unit in a choke point demands constant sensor saturation, tiered air defense, subsurface surveillance. This operational expenditure, measured in dollars and readiness cycles, frequently dwarfs the projected cost of an adversary's asymmetric attack. Their equation: low cost, high impact; ours: high cost, uncertain defense. Those figures defy conventional wisdom. The Strait of Hormuz is not a mere geographical feature. It functions as a pre-engineered kill zone. Its dimensions define the operational calculus: 30 kilometers wide at its narrowest, 50 meters deep at its deepest, perpetually congested with global commercial traffic. Iran has spent decades constructing an anti-access/area denial network tailored specifically for this confined environment. Such systems deploy layers of denial. Fast attack craft swarm the surface. Shore-based anti-ship missiles cover the approaches. Sea mines await subsurface transit. Coastal artillery targets exposed vessels. The constant clutter of commercial shipping provides both operational cover and tactical confusion for asymmetric threats. This density of non-combatants acts as a variable rather than an obstacle. It serves as a force multiplier for the defense. Targeting becomes complicated. Transit slows down. Risk increases. Every civilian hull becomes a potential shield, a potential casualty, a potential international incident. The cost of error exponentially increases. Such is the brutal arithmetic of constrained space. Iran's strategic blueprint for Hormuz avoids direct confrontation. Their doctrine emphasizes asymmetric responses. Swarm tactics are fundamental, deploying small, fast vessels in overwhelming numbers. Layered defense integrates shore batteries, drones, and naval mines. Target saturation remains the explicit goal. Generate too many threats for simultaneous neutralization. Their kill chains are compressed. Observation posts directly feed real-time data to missile crews or small boat. Launch points. Latency is minimized. They weaponize the psychological variable. The adversary's aversion to collateral damage, the imperative to avoid civilian casualties. These factors impose a critical constraint on any response. Their objective is disruption, not necessarily kinetic destruction of every target. A single disabled tanker, an oil price spike, achieves their aim. They do not seek symmetric engagement, viewing it as a losing proposition. Instead, they aim to impose unsustainable costs across economic, political, and reputational domains. This reality fundamentally alters the equation. The conventional deterrence paradigm confronts fundamental limitations in asymmetric environments. Aircraft carriers, by their very nature, become immense liabilities. Their radar signature is undeniable. Their deep-water maneuverability translates to restricted agility in constricted littoral spaces. They draw resources, becoming not just a power projection platform, but a high-value target demanding extensive, dedicated protection. Destroyers, engineered for multi-domain, peer-level threats, carry weapon systems of immense cost and capability. Deploying a multi-million-dollar interceptor against a $50,000 drone boat creates an unsustainable exchange rate. Such is the brutal arithmetic. Magazine depth, often presented as a strength, becomes a critical vulnerability. A single vessel carries finite interceptors. A sustained swarm attack, even by low-cost assets, guarantees rapid depletion. Air superiority, a cornerstone of naval doctrine, offers minimal advantage when the primary threat emerges at sea level, indistinguishable from civilian traffic operating below traditional radar horizons. The strategic application of velocity presents distinct operational drawbacks. High-performance aircraft excel at deep penetration and rapid engagement. They are engineered for strike, not for persistent, low-altitude surveillance. Their time on station, crucial for effective patrol, is measured in mere minutes, not the hours often required. Fuel expenditure for these platforms is extreme. Each sortie represents a massive operational cost, a continuous drain on the budget. Moreover, high velocity inherently creates sensor gaps. These platforms often transit too quickly to reliably detect critical, low observable threats operating close to the surface, particularly within complex littoral environments. The economic calculus shifts dramatically here. Pitting a fighter jet, optimized for air-to-air combat or high-value ground strikes, against a $50,000 explosive drone reveals a fiscal imbalance that systematically depletes resources. The mathematical advantage belongs to the low-cost swarms. Conventional wisdom fixates on capital ships and manned aircraft, overlooking a critical, evolving dynamic. The true frontier of naval power is being redefined by small, agile, networked platforms. We are talking about unmanned surface vessels, or USVs, alongside their submerged counterparts, unmanned underwater vessels, UUVs. These systems are not designed for direct engagement. Rather, they are engineered for persistent, pervasive presence. Their primary function involves data acquisition, continuous environmental monitoring, and real-time threat identification. These platforms offer surveillance at a fraction of the cost of traditional assets. Their killer metric is undeniable, a cost per hour of continuous presence that is orders of magnitude lower. A single destroyer's operational day can fund a small fleet of these machines for months. Because they are expendable, their loss does not trigger strategic escalation. Being autonomous machines rather than personnel changes the entire risk-reward equation in contested littoral waters. This reevaluation of risk enables a multi-layered defense. The first echelon: persistent intelligence, surveillance, and reconnaissance. Unmanned surface and underwater vessels are not merely scouts. They function as the continuous nervous system of the battle space. Their sensors establish an unbroken perimeter where every anomaly and signature is logged. Threats are identified, not engaged, simply detected. This constant data flow feeds the second layer: active denial. Small, networked patrol craft, some optionally manned, others fully autonomous, operate at the outer edge of the sensor net. Their mandate is disruption rather than destruction initially. They break up formations, force dispersal, and extend the engagement envelope, pushing the kinetic threshold further from the primary asset. Success here relies on a battle of geometry and timing. The final component involves precision interdiction. Naval special warfare teams deploying from high-speed patrol craft execute surgical strikes. Targets are specific, verified threats identified by the preceding layers. Rather than broad area denial, the focus remains on neutralizing the critical node or specific vector with minimal collateral expenditure. The objective is operational paralysis, not mass attrition. The crucial determinant in this complex system is unambiguous: reaction time. This single variable dictates success or failure. The operational calculus shifts from engagement range to response velocity. We speak of detecting, classifying, and then reacting within a window measured in seconds rather than minutes or hours. Such an accelerated tempo necessitates a fundamental architectural change. Decision authority cannot reside solely at a central command. It must be distributed, pushed to the very edge of the battlespace network. Autonomous systems, therefore, are not an augmentation, but a prerequisite. They process sensor data, identify patterns, and propose solutions at speeds beyond human cognitive capacity. Their algorithms function without fatigue, bias, or hesitation. The human element then becomes the critical choke point. The interface between operator and machine, the speed of data interpretation, and the cognitive load represent the new constraints. We optimize for throughput and latency reduction. Every millisecond saved is a tactical advantage gained. Such efficiency is not a preference, it is a survival metric. Escorting a single commercial vessel drastically inflates the points of potential failure. Such maneuvers shrink the operational window, forcing rapid responses. These actions expose high-value naval assets to low-cost, asymmetrical threats. A defensive posture in a domain demands offensive initiative. The cost in resources, in personnel, in opportunity becomes exponential. The underlying equation for risk remains starkly clear. Threat signature multiplied by confined space divided by reaction time determines the overall risk profile. Every element here is quantifiable. Each variable carries weight. We do not assess based on sentiment. Decisions emerge from calculated probabilities. This represents the brutal arithmetic of maritime security. We don't worship the machine. We revere the equation.